Is quantum mechanics only for particles? No. Okay, why? I'll explain. Alright, so let's go through the double slit experiment again. We shoot an electron, and the electron goes through the two slits and leaves a interference pattern on the screen, right? So the screen is a detection device. It detects where the electron lands. Okay, so when the electron hits the screen, it will be a dark spot. Therefore, we know its position. But before the electron hits the screen, it's a wave. That's why it has an interference pattern. Okay, and if we put the detection device on one of the slits, then when the electron passes through the slit, the position of the electron is localized. It's not a wave, which means it's anywhere anymore. Okay, so then when it shoots the screen, we don't see this interference pattern, right? So in summary, where we detect the electron, where we know its position, changes the possibility, the range of possible positions of the electron. And that's exactly the uncertainty principle, which says the position and the momentum of an object cannot be known exactly at the same time. Okay, it's not because our measurement device is bad, we cannot measure. No, because it cannot be known in theory. For example, let's say the position of a particle, we've measured the position of an article is x equals to 0, y equals to 1, z equals to 2. Let's say 0, 1, 2. And then we measure the momentum of the particle again. The momentum, for example, is 30. Then the position is fuzzy again. If we re-measure the position might be x equals to 10, y equals to 11, z equals to 12. Okay, so there's really no way we can know the position and the momentum. So let's use the uncertainty principle on the double slit experiment. Before the measurement, we are confident on the electron's momentum because it's a wave of a fixed wavelength of frequency. And higher the frequency, larger the momentum. So they are very correlated. But we don't know the electron's position. Okay, after measurement, we are confident on the electron's position. For example, if we put a device in one of the slits, then we know the position of the particle must be fitted within that slit. Okay, it's not a particle like the thing hit on the screen, but we know it's relatively localized. After the particle hit the screen, we have a very localized detection. The position of the particle is like a peak, right? In exactly one location, we have 100% probability of finding that particle, but otherwise 0 probability of finding that particle. It's a delta function, but the frequency spectrum of a delta function is just a pure flat, so there's no dominant frequency at all. Therefore, we don't know the electron's momentum. Okay, so the uncertainty principle is kind of easier to understand, although mind-boggling. It is not only holds for objects of like a particle, it holds for all kinds of objects. For example, baseball. Why don't we observe this kind of fuzziness on position on baseball? Because a baseball is very easy to be detected. By detected, I mean the information of the location of the baseball is very easy to leak to somewhere, right? Maybe it affects the wind, affects the grass, and it's very, very easy to get to you, the information. So therefore, we don't see the fuzziness of the baseball. And if we look at the particles of the baseball, there are like trillions of particles, right? Like the position of the baseball is the center of the mass of all the particles, right? The problem is that we don't know the exact position of every particle. Therefore, we don't know the center mass of the baseball. So, but there are so many particles. By average, the center should not be, plus minus 10 meters, right? The center, the kind of variance of where the baseball can be is there's not too much variance. It's very limited variance, right? Basically, the uncertainty of a baseball, if you stare at the baseball, okay, the uncertainty of the position is about, 10 to the minus 30 meters or something. It's basically very, 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 very hard to be detected. Okay, and maybe the answer is unsatisfying, but we can design a thought experiment to somehow amplify the fuzziness, the uncertainness of the position of the baseball. Okay, bear with me. So let's first see another variant of the double slit experiment. This is a double hole experiment, okay? You have a cube and there are two holes. The electron can come out of the left hole or the right hole, okay? And there's a mirror on the left and there's a mirror on the right. Not necessary, but you got the point. Okay, then on the screen here, we see a interference pattern, right? Although maybe, it's not stripes, it may be dots because it's not slits anymore, they are holes. But we should see an interference pattern. Now, if we do this, the particle come out of the cube will trigger a fan. So if it come out of the left hole, it will trigger a fan on the left. If it came out of the right hole, it will trigger a fan on the right. And the fan will blow the baseball into different directions. Okay, so now we put the whole system in a box that isolates everything. And there's no light from the box, there's no radiation from the box, there's no heat radiation from the box, there's no gravity from the box, which might be impossible, but let's imagine there's a box that can isolate everything. So, where is the baseball then? Well, the baseball is in superposition, right? It can be here and here at the same time. When you open the box, we will find the exact location of the baseball. But when you don't open the box, the baseball's position is fuzzy. So, I don't know if we can really do experiment like this, because the gravity of the baseball is really hard to eliminate. Maybe we can use some very, very light object and make the box really large, so the gravity doesn't make any change to the outside world. Right? And maybe it's just like a particle. A particle's gravity is like a neglectable, right? Maybe we can do that kind of experiment. But this is true. This is a true thought experiment. By definition, a baseball can be in superposition. Okay, cool. So next, I'm gonna talk about some sort of even a proof for the existence of parallel universe.